So we're going to take another look at a piecewise function, but this time there's a little twist, as we're going to see. So goal is going to be to write it in terms of piecewise functions and then take the Laplace transform. So writing this in terms of piecewise is not really the big hurdle here. We have f of t equals. Now, between 0 and 3, the function is just 0. And then at t equals 3, which means we're going to be multiplying by a unit step at t minus 3, the change in the function is that 2t comes in and 0 goes out. So we basically just have that f of t is equal to 2t times the unit step of t minus 3. Now remember, the Laplace transform of a unit step has to do with also the original function being shifted the same way. So we have Laplace transform of f of t minus t0 unit step t minus t0. Again, this is just the shortcut formula, is e to the negative t0s times big F of s, where big F of s corresponds to f of t as it was. So what we need to do is make sure that this and this are both t minus 3s. So there's a couple ways of doing this. So I'm going to just do this the old-fashioned way. And I'm going to say that f of t is equal to 2 times t minus 3 to match with the shift of t minus 3, and then add 3. And then I'm going to do some selective distributing, which is just basically saying that this is 2 times t minus 3 plus 2 times 3 unit step t minus 3, which is now 2 times t minus 3 unit step t minus 3 plus 6 unit step t minus 3. And now we notice that both the function and the unit step are in sync now. They're both functions of t minus 3. So that means we can now take the Laplace transform. Now looking at this, we want to know what the original transform f of s was. This is really f of t equals 2t, which means that big F of s is 2 over s squared. So that means that the Laplace transform of our original function of t is 2 over s squared times e to the negative shift plus Laplace transform. Now, when there's a 6, we know it's just 6 over s, e to the negative 3s as well. And there is the transform of our piecewise function.